Hey guys, morning all of you. Can you hear me? Perfect. Okay. So guys, yesterday we were starting like the quality of service, right? We were discussing about the quality of service and to deploy the quality of service, right? I think so. 1 minute. I have both types file. Like, don't say it, please. Yeah. So yesterday, if you see that we have a topology like this, right? In the 90s, 80s, what happened before the converged network? And we have some LAN network over there. There's a 500 user and these are 500 users on the different location in the Bangalore location, right? And they are some, these guys are send some traffic like voice, video and data traffic. And these guys also wants to use internet, right? So before the converged network, what happened? I need a separate connection for the each kind of traffic. Either you have voice, video, or you have a data traffic, right? And we are paying the money for the separate individual connection, right? So after that, what happened? We have come in with the converged network. So there's no issue with the in the before the converged network, right? I don't have any issue. I can send the traffic, but it's by it's not like that every user is going to send a voice traffic or video traffic 24 by 7, right? Have you making a call 24 by 7 to the any person? No, it's not. So what happened? For example, if some person had to make a call over there and say they send the voice traffic through the PST link, right? And for example 9 a.m. if they have started the journey and they're done with the 10 a.m. morning, right? So they just done the 1 hour, right? After that, what next 23 hours are you going to use the this connection, or this people is going to use this connection? No, because I'm done, right? So what happened for the next 23 or next 23 hours? What this link is totally wasted, right? Because you are not going to supposed to send, you are not going to supposed to send a voice traffic for the 24 by 7, and you're not going to supposed to send the video traffic for the 24 by 7, not even the data traffic. Okay, take example, are you going to use the internet 24 by 7? No. So why should I waste the money over there? Why should I waste my resources? So what they did, they convert this network, right? And they convert the one ISP, and that is going to carry all the type of traffic. Doesn't matter, it's a voice, video, and data. But the thing is that I need to give the preference to the voice traffic, video traffic, because for the voice and video traffic, these are the UDP based traffic. They cannot be retransmit. Okay, they can't retransmit. And other thing is that the delay of this traffic is the Cisco recommendation, right? It's not like a universal delay. The Cisco recommendation that if you go more than 150 millisecond delay is happening in your voice and video, then you have some drop over there. Some packet loss will be there. So what is quality of service? Giving the special treatment to the particular applications, right? Or managing the delay jitter packet loss in a better way is known as the quality of service. So you have a just a 10 Mbps link, and you have to manage this 10 Mbps link, right? Right now, what happened? We are giving the priority to the oxygen, right? In the COVID situation, we are giving the priority to the oxygen because that's a very important. Every medical shops are open, right? Whatever the remaining shops are there, like in the clubbings, right? If you go for the shopping malls, all those shops are closed right now because that's not a priority. Priority is what medical. So giving the preference, giving the priority to the special kind of traffic is known as a quality of service. A better way to utilize the delay jitter and the packet loss and bandwidth. So depend on the organization, what kind of traffic you will give the important. If you have a call center, you will give the important to the voice traffic and not the data traffic, of course, right? And if you have banks, then you will always give the preference to the data traffic. All good. Then after that, we have seen that you can deploy same like this example we have seen, right? This one, like we have three peoples over there, and this three peoples is doing the cleaning, making a tree and reception. So we have to pay the $100, right? So is it like that the guy A will make a tea for 24 by 7? No. Is this guy is going to make a cleaning 24 by 7? No. Is this guy is going to make a receptionist 24 by 7? No. So what happened? I just convert this 3 person into the single one, right? A single one, I'm instead of paying the $300, $100 to each person, I'm just going to hire one person that is going to make all the work. Tea, or either they can, cleaning and reception as well as. But here I have to define the priority. Hey, if you have a 5 p.m., you have to make a tea. At the same time, you got a call from the reception as well as you have to give the preference to the reception. We'll see that tea later on. That is called give the priority over there. Okay. Then after that, we have seen that in the three ways we can deploy the quality of service, or we can say the three models, or you whatever things you can call it, right? Like the if you want to make a car, or if you want to make a bike, what happened? First of all, you have to design, okay, and based on the design, you are deploying the things, right? So same things to deploy the quality of service, you have to follow the models. So we have three models. Either we have a best effort, in sub model, or differential sub model. The best effort means what? There is no quality of service. FIFO, first in first out. Whatever the traffic is coming to me first, it will go first out. There's no quality of service over there. In some order, what happened? We have to implement the RSVP protocol, and what RSVP is actually doing, it's reserving the complete path, right? We are not going to use this right now. Okay, we are using the different sub model. It's a per hop behavior. Like every router is going to look up the packet, and based on that, they will perform the decision. A very good example with the INSUM model, like if you go from the Chennai to the Bangalore, what happened? You need to book the complete flight. Okay, if you go to Chennai to the Bangalore, you have to book the complete flight. What DIPSA model is saying that, hey, I'm not going to book the complete flight. I will just take a ticket, right? Based on that, I will go, right? Why should I book the complete flight? Same thing happening in the INSUM model. What happened if this user PC1 wants to communicate with the PC number 3? They will reserve the complete path, so it's 64 kbps link, right? And next person is waiting for 64 kbps link. A complete path. That's but for this thing we need to deploy the RSVP. We need to put those some extra configuration. So to avoid this problem, we came with the mechanism that's known as a deep sub model. He's saying that, hey, I'm not going to book the complete flight, and I'm not going to reserve the complete path. Every router is going to take a decision. Okay. Now the thing is that how can you tell this router this is the voice traffic and video traffic? Okay, that we have to do the classification and marking, right? Like we have seen that on the car, if you do the car over there, if the car will be travel on the road, what happened? All these are car normal car, right? This is the road, right? On this road, what happened? This road is behave like a FIPO. First in first out. If the car number 5 is coming, it will go first, then 3, 4, so on. But what happened if the car 1 is coming, and the car 1, what happened? I put the red marks over there. That's like an ambulance over there. So what happened? All the car give the preference to this person. Hey, you can go first because you are the first preference. And how does this car know that this is the most preferred one? Because this guy has a identification. Same thing. This is the minister car, right? So if the minister car is coming on the road, what happens? Every person will give the path. Hey, take a path because you are the first preference, right? Because you are the PM car, right? So you have to take a first preference. But if the car 4 is coming on the road, he says, hey, wait a minute, let me go first, then you can go. Because you are not a special person, right? You are like me, you have a normal, so you have to wait for some time. If you get your number, you can go. Otherwise, wait for me. So this is how in the DIPSA model we are going to learn about the classification and marking, then congestion management and congestion avoidance and the policy discipline. This thing we were discussing about in the last class. Now the thing is that, okay, what is this? Now, how does router will identify, and how does router identify the packet? Like this packet is for voice, video, data, HTTP, FTP, SSH, telnet. DNS, DHCP, anything. So to identify the packet, right? To identify the packet, we need to perform the marking. Marking in the sense of what? We need to put some marking on the packet. Like we have marked the car, right? If you see, we have marked the car. Okay, this car, this was the normal car, right? On the normal car, what happened? I put the color over this. So take example, car number 3 is a normal car. I want to make this car a special one. How do I mark it? I just take a color, copy and paste, and put it over there. So now this car is now become the ambulance. So I have to put the marking. This is the normal car, right? Sorry, this is the normal packet. This is the normal packet, right? This normal packet. This is the 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 normal packet. These are the normal. These all are the normal packets. When this packet is coming to the router, right, on this particular media, on this particular media, when this packet is on this particular media, I need to tell this router one, hey, you have to give the preference to the this packet number one. Or maybe if this is the packet number 100, this is the packet number one, this is the packet number two. Take example, packet two, this is the packet three, this is the packet number four, and this is the packet number five. I'm just giving the name of this right now, packet number. I'm not doing any kind of marking right now. Packet five, and this is the packet number six, and this is the packet number, you know, 50. So normally what happened? Normally it will give the preference to the packet number one. Like first it comes, then packet number two comes, packet number three comes, packet number four comes, then packet number five, six, so on, right? And then the last come to the packet number 100. Take example, if this packet number 100 is a voice traffic. Right now, we are assuming, right? This is the voice traffic. So this voice packet, what happened? It has to be suffer, right? This voice packet has to be suffered. And what I told you, that minimum 150 millisecond, that's a recommendation by the Cisco, right? If you have a maximum, if you're going to beyond the 150 millisecond, you will have a packet loss with it. And this is the one way, not the bidirectional. It's a unidirectional. The 150 millisecond delay is the one way delay. Remember yesterday we have discussed about the delay has a four tabs, right? Two tabs. One we have a say a fixed delay, and one we have a variable delay. In a variable delay, we have a ping delay, or what was that, propagation delay, right? So if your delay is happening in this packet, what happened? Maybe the router will drop the packet, or maybe you are sending the message, hey, how are you? And the other person is only listening, hey, are you? They for they your how is drop in middle. So I need to give the preference to this packet. But before giving the preference to this packet, what happened? I need to mark this packet so that when the router will receive this packet, they will identify. And how do I marking? I need to add some tag over there. So you can perform the marking, right? You can perform the marking on a layer 3, on a layer 2, as well as on a layer 2.5 as well as. Layer 3, if I'm going to talk about, you can perform the marking in the IP header as well as, right? You can perform the marking in the ISL header, or we can say that 80.1q header as well as, because both have a marking field. And if I'm going to talk about the layer 2.5, you can perform the marking in MPLS as well as, right? MPLS header. All this guy has a field. If you have a look, IP header, format, and take a screenshot and I'll put it on the print, right? Uh, this done, and I'll take a screenshot of this guy as well as yeah, I can get from here as well as. If you see the 80.1q header, can you see the user priority in the Ethernet header, right? In the Ethernet we have a 80.1q VLAN tag. You can see the same thing in the ISL as well as. I'm not going to show you the ISL. You can take a screenshot of the ISL as well, and you can have a look the this one as well as the MPLS, the experimental bit, right? That so you can have a look now experimental bit. So I'll just paint up and this is a layer 2 header, and let me remove this guy, and let me remove this person as well. So even if you see, you can do the marking, right? I'll show you the frame relay as well as frame relay, right? Come on, but not this one. Header, yeah, this one, right? This guy. Even you can perform the marking in the frame relay on ATM as well as. This was a technique that we are not using, right? But you can do the mark. We were doing the marking, right, in the this frame relay and the right ATM as well as. So I can do one thing. I can put over there. This was like so. This bit, right, in the this is the frame relay side. We are not going to discuss, but just for the introduction, right? Discard availability. This is the one bit that we are going to use for the marking. In I think so in the ATM technology we are going to we were using the CLP something called bit hours there. We'll see that in the book is given, right? So this bit was also marking over there. If I'm going to talk about the IP header, in the IP header we have a type of service, the 8-bit field is going to use for the marking, right? Then we have in the if I'm going to talk about the layer 2 in the VLAN tag, we have a user priority. There's so 3 bits I'm going to use for the marking, and again in the MPLS header we have a 3 bits used for the marking. So everywhere, right, you can implement the, can you see that? You can implement, right, the quality of service. If you want to do the layer 2, you can do on the layer 2, you can do on the layer 2.5, you can do on the layer 3 as well as. It's up to you. But make sure that on the layer 2, you can only do the like in quality of service or because of the marking on the trunk port. Because access port, right, listen to me, access port does not perform the tagging, right? So they don't have any tagging concept. So if you don't have a tagging concept of access port, you don't have a 80.1q header, and if you don't have a 80.1q header, you cannot perform the marking, right? So tagging marking you can do on the layer 2 as well as, and you can do on the layer 2.5 by using the experimental within the MPLS header, and the layer 3 point as well as the IP header talks type of service. In this 8-bit, what happened? The TOS IP header has TOS field, all other type of service. It's an 8-bit field, right? In this 8-bit, we can say the 1 byte. We have a 1, 2, 3, 4, 5, 6, 7, 8. In this 8-bit, right, what happened? This 5 bits is reserved. We are only going to use the most significant bit over there. This 5 bits is totally reserved. In the toss, I'm again depending. We are learning the marking, how to mark the packet. So in this 8-bit, right, the we have a 5 bits is totally reserved. This is the least significant bit, and this is the most significant bit we are going to use, right? So in the 3 bits, now we have a 2 to the power 3 bit. How many values I can get? You can get the 8 values. You will have a 0, you will have a 1, you will have a 2, you will have a 3, you will have a 4, you will have a 5, you will have a 6. And you will have 7. Right? I will do one thing. Let me put this point in. So this 5 bits, the least significant bits is totally reserved. We are only going to use the 3 bits. And from the 3 bits, how many values I can get? I can get the 8 values. 0, 1, 2, 3, 4, 5, 6, 7. And each values has some name. This guy is called as a, first of all, I need to define all the 8 values. So how the things will happen, we have a 0, 0. 1 minute. We'll make 8 values. So 0, 0, 0. And then we have 0, we have 0, then we have 1, then we have 1, then we have 1, and we have 1. Same thing we have now. This guy, 1, 0. Then after that we have a, let's write on this guy as well, 0, 0. And then we have a 1. Then we have a 1. Then we have a 0. Then we have a 1. Then we have a 0. Sorry, 1. Then we have a 0. Then we have a 0, right? And then we have a 1. Not 0. This guy should be 1. This guy should be again 0, not 1. That should be 0. And this guy should be 1. This guy should be 8 values we can get. And each values has some name, right? So this value has name is like what? This is called as a default or called as a routine traffic, right? This guy has some like a, every person has a roll number. So its roll number has some name associated with this guy's called as a priority. This guy's called as a immediate. These are just a name, guys. Don't worry about that. Flash over, flash. This guy's a flash over, right? This guy's a what we call over there critical, or somewhere it's written like a voice as well. So actually this is totally reserved for the voice, right? Then we have a inter network control, or in a simple language we can say the internet, right? According to the Cisco CLI, right? Complete reserved for the layer 3 protocol, and this is the network control layer 2 protocol. This is for the layer 3 protocol. The complete EIGRP, OSPF, B, like the whatever the EIGRP, so hello packets will be exchanged, star P, all this will be exchanged through the 6. So this is just a name of the market. Right now, we are just trying to learn how, whatever the marking values we have. Like, what I'm trying to explain over there, if you just correlate, like how many card we have in India right now, like a reserved card, like red one is reserved, yellow is reserved, blue is reserved, right? So these are the markings card, right? That is reserved for the, according to the, the person to person, ambulance, the minister, the police, right? Same thing, we are just trying to find whatever the markings we have on an internet site, right? Of course, on the internet also we have some special person, right? Some special kind of traffic, like voice is a special kind of traffic, right? They don't want any kind of delay over there. So I need to tell this guy, hey, you are going to use this marking. So this is right. This is reserved. Default is reserved, totally. Reserved in the sense of what? If you're going to send the normal traffic, if you don't have any quality of service, right? Let me do, I need to just copy this guy because I need to use the same thing. Okay. So default means what? If you're not going to use the quality of service, right? If you're not going to use the quality of service, default will be sent. Like if you're sending the ping packet, when I'm sending the ping, right? Come on. When I send the ping, photo. In your IP header, right? In your IP header, what toss value set will sit out there? Normal traffic. All the number. If you don't have, like, you can simply say that no quality of service. All your traffic will mark, right? All your normal traffic will mark with dot toss 0. All your normal traffic. If you're sending a ping, if you're sending your SSH connection, if you're sending an HTTP request, all the normal traffic. Because the default 0 means what? There is no marking, right? Then after that, again, so this is reserved, right? So this value is reserved, right? Then after that, 5 is already reserved for the voice, the critical one. Okay. The 6 is already reserved for the internet control, right? A layer 3 protocol. And the 7 is also reserved for the layer 2 protocol. Although spanning tree, like DTP, BTP, all this protocol, all this layer 7 number bit is reserved for the layer 2. So how many values we have right now? We have just 4 values to use. For marking in toss, for marking, we just have 4 values. It means that you can compare like a 4 color of card. That's, we just have a 4 color of card. Now tell me, if you just have 4, because all this thing 4 is reserved, right? Default is reserved for the normal traffic. 5 is already reserved for the critical, right? Internet for control, all the layer 3 protocol like EHRP, OSPF is reserved for the 6, right? 7 is already reserved. Just have 4. Okay. So for the marking, I can use, okay, for the HTTP, I can define, okay, you are the priority, I'm going to use the 1, that's this guy priority, right? For the, I'm going to use the HTTPS, I'm going to use the 2, FTP I can use the 3, and I can use the SSH I can use the 4. Now video, which one I'm going to use? Okay, the video, which I'm going to use for the DSCP. Whatever the TFTP, 69 port number. What of the SNMP? Huh? What of the FTP now? Oh, sorry, the FTP is already done, right? What do you call of them? Traffic, NTP. Guys, I just have a 4 values. I can just allocate the marking for whom? I can just allocate the marking for this 4 person. That's it. What about the remaining person now? The video, DHCP, TFTP, SNMTP, TFTP. There's no marking. And higher toss is more preferred than lower. So if the router will receive, listen to me, if the router will receive, this is the router, and this router is receiving a 1 packet over there, or 2 packets over there on this particular interface. And this packet, take example, this is voice, or you can say that this is called as the HTTP. So this is the traffic that's belong to the voice. I can take a small voice, and this is the traffic that's belong to the HTTP, right? What I can do over there, I can put the marking of this guy. I can use the marking as a 5, right? Take example. and this is going to use the marking on this guy's of what 3 or 2, anything. So on the router, as we know that we have some queues, right? On the router, we have some queues. We'll see that. Okay, on router, have some queues, right? So from the queues, right? From the queue, what CPU will do? CPU will first pick the this packet because this guy has a 5 marking over there, and higher toss value is more preferred than the lower. But again, I just have a 4 values. On the time 90s, right? I'm talking the 90s time, it was a good enough, right? The 4 priority, 4 like the 4 tabs of this thing was enough. But nowadays we have a huge amount of traffic, right? This is not enough. This is not enough marking. This is not enough marking. Okay, this all this marking is known as a IP precedence. This is called as a IPP0, IPP1, IP precedence 2, IPP precedence 3, IPP precedence 4, IPP precedence 5, IPP precedence 6, IPP precedence 7. This IP precedence marking, we don't have enough marking over there. So what they introduce over there, nowadays, we are not going to use the toss. What we are using the DHCP value. If you see, this is the older, very older image this was. So everyone is maybe the same image. Toss, give me the DHCP value.
You mean before the type of service thing field, sir?
We know after the type of DHCP came in the picture.
Oh, okay. After the type of service.
Yep. Your toss is very older.
And the reason that got depleted is because it has only like 4-5
Only
options.
the less marking is there. Every field is same. If you just, I'll show you one minute. If you just compare with this header, where's that header now? This header to this header, are you able to see anything such in everything is same, right? The version, internet header length, forget this right now. Okay, this one and this one, right? Total length, identification, TTL protocol, every source distance, source port distance, everything is same, right? Okay, this should be not there, right? The source port distance port is not there in the IP header. Wrong images. I change with the DHCP now. Again, same size of the header is same still. The DHCP is also having the same header size. DHCP saying that hey, mine is also differentiated service code point, right? Also a 8-bit number, 1 byte we can call it. So 8 bit, how many values I can get over there? I can get the 8 values, right? 1, 1, 1, 1, 1, 1, 1, 1. Right? 3, 3 to 6, and 8 over there. In this 8 values, what happened? These 2 values are strictly reserved for the explicit convention notification ECN, right? 2 bits ECN, right? So this bit we are not going to use, right? So this is totally a reserved one, explicit convention notification.
So what did you say, sir? I didn't catch that.
Explicit convention notification ECN.
Explicit congestion notification. Okay.
Yes. Now after that, what happened? I'm going to modify this one. I said, okay, it's fine. Let me modify something else over there. This 8-bit that is reserved for the ECN, right? This guy's for the ECN now. Right? Explicit convention notification. Now we have a 6-bit left out there. In this 6-bit, what happened? Again, I'm going to do some modification over there. This 3 for the backward compatibility, right? For the backward compatibility, what happened? Now, the first 3-bit is same like previous one. The next 3-bit I'm going to use for the drop probability. So this is now, instead of the IP precedence, I'm going to define the name of this guy as a class selector, right? Only the norm and name is changed, right? Previously it was IP precedence value, right? IPVV, IP precedence value. Now this 3 bits I'm going to call this guy's IP precedence value. Now what we are doing over there, this guy I'm telling this, okay, your name is now class selector. Class selector. Again, higher is more problem. Same like IP precedence. And the next 3 bits I'm going to use for the drop probability. Now you do have a ability, right? You do have a ability to drop the packet as well. As previously it was not there. Now you do have a ability to drop the packet. Drop probability. Come on. In this drop probability, what happened? Means DSCP only used in the IP header because MPLS only 3 bits. Yes, DSCP is only used in the IP header. Right. MPLS is a different 3 bits are there. Same name is given over there, but this guy is going to use a different name. We don't have any extra marking values in the MPLS.
So just for the QoS, they changed the entire IP headers or what they defined before?
Not entire. I'm again doing this. Is an entire IP header. I'm telling you, version ISL, identification flags, total length, fragments, and header checksum, TTL protocol. Everything is same, right? Nothing is different.
No, no. So I mean, just to modify the QoS part, they changed that format.
Not the curious part, to increase the marking.
Okay.
To increase the marking, they change from IP to the DSCP. Okay, a very good example I have. PVST are there, PVST protocol. In PVST protocol, what happened? We have a topology change, right? And topology change acknowledge, right? TCN, topology notification, right? एक बिट यहाँ हुआ, एक बिट वहां, बाकी के क्या हुआ? 6 बिट, 2 3 4 5 6, all is reserved, right? So PVST was slow. What they did in RSTP protocol, this guy is going to use the all the bit TC, then TC, and then we have a agreement flag, then we have a what we call over there port roles over there, then we have a learning, then we have a what we what more, 1 2 port roles. 1 minute, what was that? Make me go check this one. I'll show you in this one. RSTP cloud sub, PVST cloud sub. TCN cloud. If you see, and I'll show you this one access, and how many bits I'm going to use over there? 2 bits. 8-bit field was there, right? The flag was 8-bit, right? Only 2 bits I'm going to use in the PVST protocol. That's why it was slow. What they did, they introduced the RSTP protocol, right? And in the RST protocol, what happened? We are going to use all the bits. See, all the bits I'm going to use to just make a faster rate. So did I change the BPDU? No, I'm just improving the things. What was the problem? The PVST, I'm just improving. The same thing is happening with the marking. IP header, IPP, right? The toss value does not have enough marking. I'm just using the enough marking, right? To just change the IP to the DSCP. Now clear, Swami?
Yes, yes. Well, yeah.
So now in this case, what happened? We have a 2 bits is totally reserved for the ECM, and now we have a 6 bit for the right. In this 6 bit, what happened? I'm going to use a 3 bit for the class selector and 3 bits I'm going to use for the drop priority. In this 3 bit, the drop priority, right? This is the new one that was not there in the IP precedence, right? I'm only going to use the 2 bit. According to the RFC, 2 bits is going to use 0 is the last bit is reserved. So this bit I'm going to use 1 and 1. So this is how your DSCP differentiated service code point, right? We have a header like this. This guy I can call instead of the calling the IP precedence value. Now this guy I'm to call this guy a class selector. CS0, CS1. Okay, I'll just move this. CS0, CS1, CS2, CS3, CS4, CS5, CS6, and CS7. Class selector 0, 1, 2, 3. Again, same name, nothing is different. Default, priority, immediate, flash, flash order. Again, this guy is going to be reserved. Default is reserved, CS0 is reserved, and the critical and internet controller and this thing is also reserved. I'll show you 1 minute. I'll do one thing. Okay, but I have to do this. I'll capture this link. Reconnect. Country interface 0/0. Address will be. Done. I'll send a packet, right? If you see echo request, IP header, which field I'm going to use? DSCP, differentiated service code point.
It's showing CS0, which means there is no QoS, correct?
Sorry?
It says DSCP CS0, which means there is no QoS on it, correct?
Yeah, of course. That is the normal traffic. DS CS0, CS payload, 0 over there. Default, routine traffic, normal traffic.
Okay, okay.
If you see the, like, I'll show the EHRP header, hello packet, which is this? CS6, right? 48 is the decimal number of this guy. CS6, right? So can you see that I'm only going to use the 110, right? 110. So if you see over there, 110, right? So if you see this guy, 6 bit, right? 1, 2. This is reserved for the CS, right? This 3 bits are going to be reserved for the drop probability, right? So I'm not using the drop probability right now. That's why it's showing the 0. And this again 2 bits is of the ECM. So total is 8 bit. And this class selector 6 is reserved for the what? EHRP. All the layer 3 protocol.
Okay, so 2 power 6 is 48. That's what the 48 is, correct?
I'll come to this 48. Don't worry. I'll leave it right now.
वही 48 आ रहा है सर, 2 power 6 करने से 48 आ रहा
मत लगा भाई.
है.
अच्छा था, मैथ अच्छा था, but okay. Now I'll talk about later. Otherwise you guys get confused right now. Okay, so this is the CS6 right now. This is here for the internal layer 3 protocol. So you know what I told you, the higher is more preferred, right? Higher is more preferred. What's the reason? The reason is very simple. Because if the router will receive, right, if the router will receive the CS6, right, if the router will receive the CS6, right, this guy, and at the same time router will receive the CS5, the voice. So which one router will allow first? The CS6 and 5. The router always give the preference to the 6 because 6 is for the protocol. So if your protocol is working fine, then you can go for the next traffic, right? This is the reason why they put the higher one. Why they put the 7 is a layer 2? Because packet is coming through the layer 2, right? So layer 2 should be fine. And the last, the default traffic, no quality of service, not giving the any preference to any one person. First in, first out. Now, the thing is that still, how many things are there? I just have 4. Sorry. I just have again 4. I can only use the 4 again. CS1, CS2, CS again. The HTTP, FTP, DHCP, NTP, whatever the TFTP now. So this class selector, the reason is to introduce the class selector over there again to just provide the backward compatibility to the IPP, or we can say the TOS. CS provide, or we not CS, we can the complete DHCP provide the backward compatibility with IP distance. So we can the TOS. So if any packet, right, for example, if any packet is coming with the IP precedence, right, 6, it will router will convert into DHCP 6. It's a backward compatible, right? That's why we use this 3 bits. But again, same marking is there. So now what happened? How still I haven't used this guy right now. So drop priority. How many bits we have? 2, because 1 is reserved. So 2. How many values I can get over there? Oh, it means 0 0, then 0 1, then 1 0, then 1 1. Again this is reserved, right? Equal to the RFC. Again this is the result. Then again 0 1 is what? That's the routine, right? Routine traffic. Now again next one is what? Next one is called as a low drop. Third name is, this is just a name again I'm repeating. Medium drop. High drop. These are just a name. Now, how many values we have now total? So 3 values over there. Sorry, 4 values over there and 3 values over there. Now let's do one thing. Combine this guy. Add this person. Make a addition. Make a addition. If I'm to add this person, what happened? We have a CS1. We have a CS number 2. We have a CS number 3. We have a CS. Again, I'm repeating. We are just trying to improve the marking because again, we are the same marking, only 4 marking years there. I'm just improving the marking. Now, how many values in the drop priority we have? Low, medium, high, right? So we have a low, we have a medium, we have a high.
CS 0567 will be associated with the drop probability 0 reserve.
No, again, come back again. Low, sorry, Saurabh.
CS0,
CS0,
CS5, CS6, CS7.
CS5, CS6, CS5 and CS6 is reserved, right? This is for the voice.
Yeah,
CS,
all these are reserved.
yeah.
Even CS0 is for the default. So
CS0
all
is for
these
the
are
routine traffic. It's not, it's a routine traffic. There's no
not
quality of
participating.
service.
Yeah.
Yeah, there's no
So
quality of
they are
service.
participating with the which drop selector? Drop probability 0.
They are not selected with the 0 over there.
Okay.
They are not, it's not right. These are the totally different. These are the totally different. These are totally different. And this class selector is totally different. This bit is reserved.
Okay.
I'm not associating this bit with the any of the class selector of them.
So my question is, in DHCP, definitely this CS567 is also associated with the some drop probability.
No, if you now make a drop to the this guy, you can drop it, but you're not going to call this guy with the this values, right? This drop priority values. Drop priority. These are the bits through the bits through listen through this bit. I'm just improving the thing. Just give me 10 minutes. Your question will be clear, right?
Okay.
Just give me 10 minutes.
Okay. Okay.
Now, then we have a low, medium, high, and we have a CS. These are the CS value that we have 4 values over there. Guys, have a look over there. These are the 4 values we had. Okay, this CS values are used over there. I'm making an addition, right? So CS 1, 2, 3, 4, and we have our 3 values of low drop, medium drop, high drop from the drop value, right? Because this bit is totally reserved. Okay, so I'll make it 0. So now we have a low, medium, high.
What is that last bit again reserved for, sir? That 0? You're telling why is it reserved? Then
This is the reserve. This is the reserve value for the drop priority. Like this one is a reserve for the CS0. Again, for in the drop priority, what happened? The default one is the reserve.
No, not that one, sir. The one that last digit. I mean the 0 1 1 0 is there, right? So again
Where is
there
the
is.
one? Where is the 110?
सर वो ड्रॉप प्रोबेबिलिटी के नीचे
ये
वो
वाला
0 है
ये
ना.
this bit is always set to the 0 in your IP error. It's no, we are not going to use it's reserved for the future extension. I don't know why they are reserved for the future extension, but this is reserved. This bit always set to the 0, always.
Okay.
Now we have a this drop. So from here, I'm going to make a more marking. I'm going to call this guy out if11. Why I'm going to call this guy the if11 12. I'll let you know 1 minute. If12. They are just a marking values af13, af21, af22, af23, af31, af32, af33, af41, af42, af43. Now the combination of this thing, the DHCP value, or sorry, see class selector values or drop priority is going to make a result of what? Is going to make a result of assured forwarding. This is the another marking filter. And in the Azure forwarding, this is the syntax is called as Azure forwarding. In this Azure forwarding, what happened? How many values we have now? We have almost 12 values. So previously we have a 4, now plus 12. This is called as 16 values. AF is what? This is the syntax AF X or Y, right? Here the X is going to represent, this is the value that's X, right? This is the value X. This is the syntax of that one. So X is going to represent that is your CS values and Y is going to represent its a drop probability. So it means that what I told you that higher values, right? Higher CS value is more preferred, right? More preferred. Low drop probability, more preferred. So in this case, what happened? We have a values of the AF 11, 12, 13 for the Azure forwarding 11, Azure forwarding 12, Azure forwarding 13, Azure forwarding 21, 22, 23, 24, 31, 32, 20, 33, 41, 42, 43, right? Now, in this one, what happened? AF 11, right? This value is X, this value is Y. It means that this value is going to represent what? Class selector, and this value is going to represent drop parity. Same thing, we have AF 43. The 4 is going to represent what? Class selector, and DP is going to represent this way. So class selector is higher is more preferred. This is the lower is more preferred. Higher is more preferred, lower is more preferred. Same way, we have another values. We have a AF 41, right? Class selector, higher is more preferred, and lower is more preferred, drop priority. So it means that if the router will receive a two packets, packet number 1 and packet number 2, and in this packet now I'm going to use some marking values from there. I'm going to assign the marking is a AF 43. Take example, I'm going to assign the AF 41. Router always give the preference to the AF 41 because AF 41 is saying that hey, higher CS, lower drop priority, higher CS, lower drop priority, right? So can you see that the 43, right? The 3 is there. So these values are same, 4, 4 are same, right? So it will tie. Now what happened if we look up the 3 and 1? So 3 is what? Lower is more preferred, right? In the drop parity, what happened? Lower will be more preferred. So what happened? R1 will always give the preference to the A41, not to the 43. Same thing, if I'm going to take example of this line, AF11 or AF13, which one is giving the more preference? Always this will give the more preference. So like this will follow like this. We have a like this one. Then we have a 31 to 32 to 33, then 21, 22, 23, and then we have 20, 11, 12, 13. So starting from the down, down, up, 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 up. AF41 is more preferred than the AF42 and 43. AF31 is more preferred than the 32 and 33. AF21 is more preferred than the 22 and 23. And AF11 is more preferred than the 11, AF12 and AF13 over there. So total we have how many values we have? 16 marking. Previously it was 4 the class selector, then 12 I'm going to make Azure. This is called as a Azure forwarding. The combination of CS plus property. So the total we have a 16 marking. Except this one. Except this one, we have another cap of one more marking is there. That is called as a AF marking. expedite forwarding. Expedited forwarding. This expedited forwarding is more prevalent. So AF11 and AF40 and AF41 is more. AF11 and AF41. AF41 is more. Yes, right, Devinder. AF41 is more prevalent. Higher CS value, right? This is the higher CS value. So AF is the expedited forwarding. Except this, the class selector. So now see, understand over there. We have a class selector. That's a 4 values. Then we have our AF values. We have a total is 12, right? And except this one, we have EF values over there, and that is called the one value. This EF value is more preferred. Is more preferred. If the router will receive CS values, if there is the AF values, and it will receive the EF values, CS, AF, or EF, router always give the preference to the EF values. And it is a recommendation to use the AF values for the voice traffic. Highly critical traffic. It's a recommendation to use the EF for the highly critical traffic.
So between CS and AF, which is more preferred? Like if you have CS,
AF, AF. So now these are the markings, right, for the layer 3. If you have a look, I'll show you. Class A, class my PMAP, class ABC, set. Which value I'm going to say? I'm not in DSCP. DSCP, if you see how many errors we have now. AF 11, 12, 13, 14, 21, 22, 23, 31, 32, 33, 41, 42, 42. Cause backward lay 2, right? Set the packet from the lay 2. CS1, CS2, CS3, CS4, CS5, CS6, CS6, and default traffic EF and PF servers. If you set the IP precedence, right? How many values we have? This is just a name, right? That I told you, right? This is just a name of that one. Just one. You know, have a look over there, right? The name. So 7 values are there. Critical, we have flash over there. Immediate internet for the layer 6. Sorry, say IP6. IP precedence or precedence is there, right? Network. Then we have a that is called as a what 7, and then priority is 1, 14 is 0. Just a name. These are the IPs values. These are the DSCP values. These are the markings that we are available with the IP.
So sir, those PP thing is don't exist anymore.
Sorry.
That PP thing, what was before CS class selector? There was another torch field.
मतलब मैं समझ ही नहीं पा रहा हूँ क्वेश्चन क्या बोलना चाह रहा हूँ.
DHCP से पहले एक टॉर्च फील्ड था, तो टॉर्च फील्ड की जो मार्किंग्स थी दैट आर नॉट अवेलेबल एनीमोर.
ये रहा ना, ये रहा टॉर्च फील्ड, ये रहा ना सारा, ये ना आईपी प्रेसिडेंस वाली, ये तो है आईपी प्रेसिडेंस.
हाँ ये रहा. ओके ओके ओके.
These are the DSCPs. So they are the backward compatible, right? See, can you see the precedence 1, precedence 2, precedence 3, 4, 5, 6, 7, backward compatible.
Okay.
All these markings are present. And first of all, I'll tell you, it's not like that you can send your traffic any marking values. You have to purchase this thing. It's not free, right? It's not free. अगर तुम set कर रहे, if you're going to use the EF marking, of course, EF is more preferred, right? So if you're going to use the EF marking, okay, what happened? If you're not going to inform to the ISP, hey, I'm using the EF marking, they will drop you. They will drop your packet. because you have to pay the money for the marking. It's not a free. मैं ये use कर लेता हूँ, I will use this one, I will use this one, I will use. You have to pay the money. Free कुछ नहीं दुनिया में.
मैंने pay
So
is free if you want to put our traffic on the service provider network, right? अगर internally हम लोग को सिर्फ mark करना है तो why do we need to pay?
Internally तो कुछ internally क्या mark करने की जरूरत है भाई?
जाएगा तो इंटरनेट पे.
No, basically what I'm trying to say is sir, like अगर मेरे को LAN में if I have data traffic, voice traffic and everything,
mark करो कोई दिक्कत नहीं है.
हाँ तो फिर internally I can do it, right? I want to prefer voice internally first. WAN पे तो कैसे भी वो हम कुछ
यार
नहीं कर.
internally में तो 1 gig के link लगे होते हैं, क्यों करना? Internally में तो इंटरनली तो 1 gig के लिंक लगे होते हैं, भेज दो ट्रैफिक जिसको जितना भेजना है, डेटा ट्रैफिक तो जाता है मस्त इंटरनेट पे. प्रॉब्लम आता है वैन पे, हमेशा वैन पे इशू, द इशू इज कम्स फ्रॉम द वैन साइड, नॉट द लैंड साइड.
लेकिन ये WAN पे जो हम मार्किंग करते हैं सर, कैन बी एक्चुअली विल द सर्विस प्रोवाइडर अंडरस्टैंड दिस मार्किंग ऑन इंटरनेट नेटवर्क?
Of course,
Yeah,
buddy. Every that's what the behavior, the per hop behavior. What I told you, the per hop behavior, PHB, the differentiated service that what was there, a differentiated service model, PHB. Every router will understand.
Router will understand, but will the service, because what I'm trying to say,
आप जहाँ पे भी हैंड ओवर करोगे ना इंटरनेट को, वो जो डिवाइस रहेगा सर्विस प्रोवाइडर का एज डिवाइस, वहां पे आपका क्यूओएस डिफाइंड होगा आपके हिसाब से एज पर योर लैंड नेटवर्क, जो भी आपका और सर्विस प्रोवाइडर का डिस्कस रहेगा.
हाँ, what I'm trying to say is sir, लेकिन सर्विस प्रोवाइडर अगर आप इंटरनेट सर्किट लगाओगे, so there will be so many handovers, right, on the internet circuit. Will the service provider take care of using, preserving your marking across every hop?
एक मिनट. हाँ, पूछ क्या पूछा था?
Sorry sir, can you hear me?
हाँ, बोल. Yes, I can hear. Tell me.
हाँ so what I'm asking is like we put this marking sir, like voice circuit में इतना चाहिए, data circuit में इतना चाहिए, and I'm actually offloading it to my internet service line. Okay, on the internet, basically I'm taking connection from Verizon, but it uses so many other third-party services, and basically finally it reaches the destination wherever I want. So now the service provider will actually preserve this entire marking across all the different.
Exactly right. You are not entire. If you set the marking on the router number 1, router number 2, router number 3, router number 4, router number 5, router number 6, 7, 8, 9, 10, and n number of router will understand that marking pattern. You don't need to apply. That's why it's a PHP, per hop behavior. Every router is going to make an independent action over it.
But एक customer का if he has to do so much, then basically it's so difficult, no sir?
कैसे difficult है तुम बताओ? मैं हर router पे थोड़ी लगा रहा हूँ. I'm not applying on every router.
नहीं, what I'm trying to say is like अगर मैं एक edge router हूँ sir, अगर मेरा company Cisco है, and then imagine there are thousands of companies like Cisco, and if the service provider has to basically preserve the marking across each of these enterprise solutions, right? So he will have to tag everything, right? Like Cisco ka traffic ko, I want this marking to be preserved. So like that, service provider will actually preserve that marking you're saying across each circuits?
Yeah, of course. तुम एक बात बताओ, मार्किंग कहाँ करते हो? तुम अपने साइट से कम्युनिकेशन करने के लिए करते हो ना?
हाँ.
कि तुम इंटरनेट पे जाने के लिए मार्किंग करोगे पैकेट को?
सर मैं what I was thinking sir, अगर मेरे पास कोई voice solution है, like if I have a voice का क्या बोलते हैं, Avaya something, right, internally, and I'm not, so for that what I will do is I'll do a marking so that my video conferencing which is in this particular ये है, so I will give preference that none of my voice traffic drops as compared to video, right? And as compared to video, my data can drop, but video cannot drop. So I will basically use those markings in that fashion.
Okay. तो तुमने अपना मार्किंग लगा दिया. सुनो मेरी बात. तुम you can do only, you just say the marking on the packets, right? कि मैंने ये मार्किंग लगा दिया voice traffic के साथ. Okay. And then you will send that packet to the ISP. Okay. Now, if you had paid the money to the ISP for the marking, then ISP will allow that marking packet. If you haven't paid the marking, okay, then what they will do, They will convert whatever the marking you have, EF values, EF41, EF42, anything. What ISP will do over there, if you're sending this kind of packet to the ISP, right, and you haven't paid the money to the ISP for the marking, ऐसा नहीं कि ISP तुम्हारा पैकेट को ड्रॉप करेगा. It's depend on the ISP. Maybe they will drop you, or what they will do, either they will convert into the CSU default packet. भेज दो.
अच्छा. Okay. So
no, in that case, if suppose we bought the bandwidth from ISP and we used DM VPN and then we did the marking.
Tell me one thing. Are you through the DM VPN? Are you sending the packet through the physical media or the tunnel media? But still, you are utilizing the bandwidth of the physical, right?
Through tunnel.
But still, you are utilizing the bandwidth of the physical or not the tunnel, right?
But
data will flow through the physical media only.
But your packet will still moving through the physical media. No, your tunnel.
But the
yeah, tell me.
ISP will not know about that what we are doing on the.
But you are consuming a bandwidth of the physical. But you are consuming the tunnel. But you are consuming the bandwidth of the tunnel interface, right? Sorry, physical media.
That will not understand that encapsulated packet, but the
packet is encapsulated.
Underlay is still the same.
See, the packet you have said that okay, the source is 101.1, destination is 202.2.2, and I'm going to encapsulate this packet with the DM VPN. You are still going to use the 2 Mbps link, right?
The packet is encapsulated, right,
so
sir? So how will the service provider know what marking have done?
Packet तो तुम अभी भी physical media से ही transmit कर रहे हो ना?
हाँ, लेकिन still he cannot open that packet.
एक बात सुन, listen to me. मैंने ये सारे 2 Mbps bandwidth है ना किसी और को दे दिया. मतलब my manager is using this 2 Mbps bandwidth, right? This manager, क्या तुम भेजोगे पैकेट ये? मेरे पास bandwidth नहीं available है. I don't have a bandwidth available on the physical media.
Okay. No, but my question is not with respect to bandwidth. My question is like, can the service provider open that packet? Because it's encapsulated. Of course,
they are not interested to open the packet. Why they will open the packet?
No, but encapsulated है. अगर आप voice traffic को prefer कर रहे हो, so
voice traffic. So 1 minute, एक मिनट रुको. तुम पहले what you are telling you want to give the preference to the tunnel traffic?
No, tunnel के through ही मैं voice traffic भेज रहा हूँ, sir.
तो उसको preference देने के लिए, if you want to give the preference to the tunnel traffic, then you need to implement the quality of service on the tunnel interface. नहीं तो एक बार try to understand this part. 1 minute. This is my ISP, right? मैंने यहाँ से एक DMA बना दिया. अब मुझे बताओ, this is the link of the physical media. ये मेरा क्या logical connection है, right? This is my logical connection.
Yeah, that's an overlay.
Overlay. So am I sending the packet through the overlay? हाँ, बताओ. हम तो वायरलेस तो यूज नहीं कर रहे भाई. कर तो रहे वायर्ड मीडिया अभी तक still.
सर ऊपर क्या लिखे आप? Wireless, okay.
I'm not using wireless. I'm still using the wired media, right?
Overlay will travel from underlay only. If the underlay is not reachable, let's say underlay get disconnected, will you be able to transfer your data from overlay?
Not possible, right? Your underlay must be present because still my traffic is falling with the physical media, right? Physical media. And here, take example, what happened? I give the preference to all the this packet, right? Or whatever the packets that go through the underlay. So what happened? Am I able to give the preference to the overlay packets, whatever the packets coming through the VPN? No. In that case, if you give the priority to the overlay packet as well as, then you need to implement the quality of service on the tunnel interface as well as. ऐसा ही अभी तो पहले मेरे पास क्या था? I just have a separate network, right? Underlay. मैंने एक overlay नया network बना लिया. अगर तुमको quality of service यहाँ पे भी preference देना है, then you have to apply the quality of service over there. But still, तुम एक बात मुझे बताओ कि मैं जो overlay के through packet भेज रहा हूँ, still वो packet कहाँ से जा रहा है मेरा? Underlay के through, right? Still my packet is moving through the underlay. मेरा बैंडविड्थ तो यही इंटरफेस यूटिलाइज कर रहा है ना। ऐसा थोड़ी ना है कि मैंने डीएमबीपीएन इंप्लीमेंट कर दिया और मुझे 100 मेगाबिट्स स्पीड मिल गया और मुझे 1 गीग का स्पीड मिल गया, ऐसा नहीं है ना।
तो आप जब यूएस ओवरले पे कर रहे हो, I mean still your ISP can open that packet. Is that what you're saying? Because
मैंने कब बोला ISP will open the packet? मैंने
because
बोला
how will he see what is the toss that you have put, sir?
अरे ISP को क्यों देखना, वो तो राउटर देखेगा ना।
हाँ, I mean वही तो फिर उसका मीडिया है ना सर, that's the media that we are using, right, to transfer the traffic.
तो वही तो मैं बोल रहा हूँ, तब तो इसलिए तो मुझे क्वालिटी टनल इंटरफेस पे क्वालिटी ऑफ सर्विस लगाना पड़ेगा ना, तब तो वो राउटर को पता चलेगा अच्छा ये पैकेट इनकैप्सुलेटेड पैकेट है, तब तो उसको पता चलेगा कि मुझे इस पैकेट को प्रेफरेंस देना है क्योंकि इस पैकेट में मेरा वो लगा पड़ा है AF वैल्यूज।
Correct. So encapsulated packet रहेगा. He can see the source, destination, and whatever. But can he see the fields inside that packet?
Of course, that's the router is behavior, per hop behavior। मैंने जब EF का पैकेट लगा दिया है उसके अंदर AF वैल्यूज लगा दिए तो वो देखेगा ना।
Even though the packet is encapsulated.
So what happened? फिर तुम बोल रहे हो इनकैप्सुलेटेड, मैंने क्वालिटी ऑफ सर्विस लगा दिया टनल पे तो वो देखेगा। अगर मैं क्वालिटी ऑफ सर्विस टनल पे लगा दूंगा, इफ आई एम गोइंग टू अप्लाई द क्वालिटी ऑफ सर्विस ऑन द टनल, वो देखेगा। अगर नहीं लगाऊंगा तो वो नहीं देखेगा। इफ आई एम नॉट गोइंग टू अप्लाई द क्वालिटी ऑफ सर्विस ऑन द टनल तो वो नहीं देखेगा, तो उसको नॉर्मल ट्रैफिक कंसीडर करेगा, उसको नॉर्मल भेज देगा।
अच्छा, ओके।
तुम यहाँ पे समझो कि पहला बात,
but ISP doesn't have this is my this is my bandwidth. ISP doesn't have to do anything what I am doing my interface, because this is just they are giving the pipe one end to another end.
Okay, they are just giving the pipe, understand? Okay, at this point they just give the pipe. Okay, now tell me, you have a data traffic, you have a voice traffic, you took a pipe for the 2 Mbps link, right? Then okay, you have a data traffic, you have a voice traffic, you have a HTTP traffic, you have a TFTP traffic, lots of traffic is coming over there, right, on the same router. Now do you need to apply the quality of service over there? You want to apply quality of service to give the preference to the voice traffic?
Yeah,
you want to give, right? So तुमको ISP को बताना पड़ेगा।
Basically all the traffic will go through the tunnel, and only we are giving the preference the voice traffic inside the tunnel.
Devinder, forget the tunnel right now. Forget the tunnel, because I haven't configured anything. We haven't seen any configuration part of the quality of service. That's why you are not able to understand things right now. Okay, forget the tunnel right now. Tunnel is a very high level things, right? How we can apply the quality of service on the tunnel and how does they will react the packet. We'll see that. Okay, right now try to understand, when I'm sending the packet, right, I need to do the marking. And once I do the marking, I need to also inform to the ISP. I'm doing the marking. If you're not doing the informing to the ISP, what ISP will do?
Sir, can you hear me?
Hello? What ISP will do, if you're not going to inform to the ISP will convert all your marking into the default one. I'll show you this practical as well. As ISP do have an ability, right? They can convert your all marking into the default one. No preference. I can't hear you. Exactly, without informing the ISP treats as a default traffic. I can't hear you. I think so your side is Swami. Wait for the one more day, when so we see the practical now, then you have a clear picture of this thing. Don't worry. You have to pay the money to the ISP. It's not free, right? You have to pay the money to the ISP for the marking. Swami, can you hear me? Swami, can you hear me? Voice that usually use voice gateway, right? Voice that usually use voice gateway, right? I didn't get to see on the voice. They usually use voice gateway. Voice gateway in the sense, like a voice traffic IP phone you're talking about? Yeah, of course. IP phone is talking just voice router, of course. But again, you have to give the preference because you have a single connectivity with the different branches, right? If you have a use like yesterday, I told you right now. 1 minute, sorry. Yesterday I told you right now, if you have a if you have a 100 Mbps link And if you have 200 Mbps link and you just have 100 users in your network, no need to do the quality of service. No need. If you have a separate connection for the PST and you have a separate connection for voice, no, if you have a separate connection for the data, no need to do the quality of service. Why we are using the quality of service? You just have a very limited resources. You have a limited bandwidth. And in that limited bandwidth, you need to give the preference to the every person. Understand the need of quality of service. The need of quality of service, we are just giving the preference. Guys, it's not a hard topic. Quality of service is a very, very easy topic. Only the thing is that the terms are new, nothing else. Need of quality of service is very simple. We are just trying to use, right, in a better way. We have to use the bandwidth in the better way. Otherwise, we have a lots of things, right, without information with the quality of service, with the local to the branch one in, and that user actually don't need to exactly. Then the now clear the things a little bit. Don't worry, your things will be clear by tomorrow. That once we see the configuration part now, things will be clear, more things. I'm going to save this one. All good, guys. Any questions, anyone?
Sir, on you said that on L2 layer 2 switches हम लोग QoS ट्रस्ट पोर्ट पे लगाते हैं,
हाँ.
वहाँ पे टैगिंग होता है. हम लोग जब वॉइस फोन्स लगाते हैं तब स्विच पोर्ट पे वो वॉइस अलाउ करते हैं उसमें.
हाँ हाँ.
तो नॉर्मली हम एक सेकंड, ये हम लोग एक्सेस पोर्ट पे लगाते हैं, ट्रस्ट डिवाइस सिस्को फोन एंड ऑटो QoS
Access, that is the auto QoS is the mechanism that you directly implement the voice traffic, right? Auto QoS, right? Yes, you're correct. Yep. Go on. So you तुम कहाँ पे लगाते हो? एक्सेस पोर्ट पे.
एक्सेस पोर्ट पे लगाते हैं. ये जरा थोड़ा सा इसको थोड़ा समझा दो.
एक मिनट. तो ट्रस्ट डिवाइस इसको फोन
यहाँ पे
तुमने ऑटो क्यूस लगा दिया वॉइस सिस्को फोन पे, ठीक है. तो तुमने वो बताया कि तुमने ये बताया उस राउटर को कि जब भी मेरा ट्रैफिक आए ना तो यहाँ पे क्वालिटी सर्विस इंप्लीमेंट कर दो ऑटोमेटिकली. मतलब ऑटो क्यूस में क्या होता है पता है? ऑटो क्यूस एक ऐसा फीचर है ना वॉइस, ये वॉइस के लिए सिर्फ होता है, डेटा के लिए नहीं होता है.
वॉइस के लिए ही है ये.
तो ये क्या बोलता है ना कि तुम इसके लिए क्वालिटी ऑफ सर्विस इंप्लीमेंट कर दो और इधर से जो भी जितनी भी पैकेट है ना उसको फर्स्ट प्रेफरेंस दो एज कम्पेयर टू एनी अदर वन. और ये क्या करेगा, उसी समय क्या करेगा, मार्किंग सेट कर देगा और वो आगे भेज देगा राउटर को नेक्स्ट स्विचेस एंड व्हाटएवर द इंटरमीडिएट डिवाइसेस कमिंग ओवर देयर. सो अगेन क्या होगा, मान लो कि लेयर 2 का डिवाइस है तो वो लेयर 2 पे पैकेट मार्किंग करके आगे भेज देगा लेयर 2 को लेयर 2 को लेयर 2 को. और इन बिटवीन इफ यू हैव अ लेयर 3 तो वो मार्किंग लेयर 2 से लेयर 3 पे कॉपी हो जाएगा और लेयर 3 से वो आगे चला जाएगा इंटरनेट पे. और इंटरनेट पे इफ समहाउ MPLS is there, then IP marking will copy to the MPLS header.
तो पोर्ट लेवल से ही वो मार्किंग करके ही ट्रैफिक फॉरवर्ड करेगा.
Exactly right.
But seriously, we need to implement the QoS on the LAN network because we have already enough bandwidth in the LAN network.
Yep, Devendra, tell me.
I told seriously, we need to implement the QoS in the LAN network.
There is no need.
There is no congestion.
Yeah, there is no congestion happening.
Yeah, most of the times.
There is no congestion on the LAN. That's why we are not going to implement over there.
I think we have a lot of doubt that will be clear in the next classes only.
Yeah,
then we will learn more.
Yeah, I lost you in the middle. Swami, don't worry. We'll discuss this thing. Okay, later on. Let me complete the basic thing because the auto queues the sort of has idea. That's why I explained a little bit. Otherwise, I have a we'll later be discussing of the auto queues as well. We'll see that later on. Regardless of the VPN or physical interface, need to do inform to the ISP. First, buddy, if you do the mark, see simple language. if you do the marking, if you implementing the quality of service on the WAN side, doesn't matter. If you do anything connection, doesn't matter. Your VPN connection, you need to inform to your ISP. Simple language, you have to inform. Otherwise, they will drop your packet. I'll show you, right? I'll show you. I'll assume one router as an ISP, and you are not going to pay the money to the ISP. And for example, this guy's in the marking values. What ISP will do? ISP will convert, right, into the default packet. And उसके बाद क्या होगा? Default जाएगा. अगर राउटर को एक्सेप्ट करना हो तो करेगा, नहीं करना हो तो स्टॉप कर देगा. All good?
Sir, within our data center environment, we don't use QoS, sir. Like अगर मेरे
Yeah, देखो ऐसा क्या है ना कि not used. ऐसा तो मैंने कह सकता कि not used. Okay, because everyone has a requirement of the different things, right? On that day, I give you the one example, right? Remember कि हर चीज का requirement है. तुमको बस पता होना चाहिए. You must need to know that thing only. Otherwise, everything is necessary.
Okay.
Wait for the tomorrow. You will understand the tomorrow once I do the practical now. Then all those things will be clear. How the I'm telling you, it's not easy now. मैं सही बता रहा हूँ, बहुत ज़्यादा easy है. It's very easy. Quality of service not a hard. You just need to understand the things. That's it. Nothing else. इससे ज़्यादा easy कुछ नहीं है. Quality of service से ज़्यादा easy. कुछ क्या करना है तुमको? मार्किंग पड़ा है यहाँ पे. कॉन्फ़िगर में रखा हुआ है. कॉन्फ़िगर से यहाँ से कॉन्फ़िगर से मार्किंग को उठाना है. राउटर पे जाओ, मार्किंग उठाओ, मार्किंग सेट करो, भेज दो. बाकी तो राउटर कर रहा है ना. यू आर नॉट गोइंग टू डू एनीथिंग. एवरीथिंग इज डूइंग द राउटर. दिस मार्किंग उठाओ, जो मार्किंग उठाना उठा लो, आईएसपी से पूछ लो, भेज दो. बाकी काम तो राउटर का है. राउटर को लेट देम राउटर डिसाइड ओके व्हाट शुड दे विल डू विद दिस पैकेट. तुमको नहीं लगाना भेजा यहाँ पे, सारे राउटर लगाएंगे.
Okay. So, but yeah, it should preserve it and you should pick it, right? So basically, if you send it on R1, R2 will pick it and basically use the same marking and forward the packet, correct?
Yeah, same. All of the intermediate router will do the same thing.
Okay.
That's why it's calling the per hop behavior. Why I'm saying the per hop behavior? Every router is going to make an independent decision. All good. So I'll see you tomorrow. Bye bye.